Yes, good morning, everyone. As far as the previous class is concerned in the operational research, we have discussed regarding the replacement theory and different factors containing in the case of this replacement and different conditions that arises for the replacement within the industrial sector and in the general way of manufacturing in any of the kinds. And in the today's class, we'll be looking after the different cases of this replacement theory. Moving on to the initial conditions of the replacement that I just recall in one or two points. First one is do not replace if the next year's maintenance cost is less than the previous year's average total cost. That is, when the total average cost has been considered when related with respect to the previous or next year's maintenance, and it has been less, that it should not be any replacement because they will be within the feasible conditions. That will be in the feasible conditions. The next point here it is replacing if the next year's maintenance cost is greater than the previous year's average. So vice versa, the initial point specifies the unbalanced condition of the overall maintenance releases towards the average cost that is being maintained. If it is very greater, then the replacement is necessary. So in the yesterday's class, we have gone to a problem related to this towards the first condition. That is, a machine is continued up to the time the average cost per year, that including the new machinery cost and maintenance cost, and the miscellaneous cost, that is nothing but the tool that has been changed or restriction of tools, interruptions, timings, and maintenance timings cost, and the overall operational scenario costs, etc. of that particular machine decreases and is replaced at the time when its costs begin to increase. So this is the major constraint that is being erasing. So by considering the overall estimation, including all the costs, including the input cost of the machinery, investment cost of the machinery, if the maintenance and all the expenses has been considered in such a case, what is the replacement time period? So this is the condition that is related to the phase condition 1 or case 1 related to the time factors. And in this time factor, year by year, the running cost has been given, and depending upon that, the resale value also given here. So replacementing of the truck under the characterizations. So this the solvation procedure that we have been seen in the previous class, and in the mean year of this 50 year, as per the statements related to this replacement theorem that we have, in the fifth year, it is being crossing the total maintenance cost plus the input cost of the machinery, and hence that machinery should be replaced in the fifth year. That specifies very much clearly. So in the fifth year, as per the statistics, the running cost is 1,000 rupees. It clearly specifies, and resale cost is 500 rupees. So here in the fifth year, so when crossing towards the fourth year to fifth year, there is here 1,000 rupees. So up to this 6 plus 7, 7 plus 6 plus 7 plus 8 plus 9 plus this 1,000. So overall cost that 4,000 rupees of total running cost upon average of this 5 years of term period. And resale cost also, when it has been considered, this 2000 plus this 1,333,750 and 500. So it is being decreasing simultaneously, and the maintenance is being increasing. So the characterization is 50%. When nominally in the question that if you have been observed, this 500 of resale value with respect to the running cost is 50% in the variation. So the initial cost of the bike, it is total cost, it is 3,000, and even maintenance plus running cost is 1,000 in the fifth year, only in that particular year. And when compared on average of this 5 years, it is 6,500 rupees. So the depreciation cost, deviation cost, it is 6,500 in the case of this total average section. When the consideration has been happened between total running cost and depreciation cost, that is nothing but initial cost of the bike minus the resale value, that is 2,500. So almost 75 percentage of the value has been accredited here. So the total cost is 6,500, and the average cost per year, that is divided by 5 if you have been considered, then 13 5 65. So upon an average of 5 years, 6,500 divided by 5 years, it leads to the 1,300 rupees. So 1,300 rupees, and the overall cost of this bike at an initial range, it is 3,000 rupees. So the replacement is quite necessary because of the factors here. There is, here we are having the two different conditions that have been already discussed. Do not replace the next year's maintenance cost is less than the previous year's average total cost. So here moving on to the average total cost. So average total cost, it is 1,300. So it is decreasing average cost and almost similar in strategy. And when compared to the total cost of the accessory, it is gradually increasing, and this is almost feasible with respect to the previous year. And another one more point that we are having, replace if the next year's maintenance cost is greater than the previous year's average total cost. So maintenance cost and total average cost. So here total average cost, it is 1,300 that we are getting, and it is, in the case of descending strategy, it is very much, it's slightly less when compared to the previous year, and lead to get the replacement in strategy. So in the average strategy, there will be a slight decrement, and gradually it is increasing furtherly. So hence, it is required in the fifth year of replacement. Moving on to the second condition. So similar problem will be having the condition here in the second strategy, that is machines in a factory have increased cost as they continue in service due to the increased running cost. The initial running cost is 3,500 rupees, and the resale price drops as the time passes until it reaches a constant value of 500 rupees. So this determine the proper length of service before machines should be replaced. Cost data are given below in the tabular column. So here they're asking that machines which are increasing in the cost and even the servicing point due to the running cost, that is nothing but if the continuously any of the automobile has been utilized, automatically the maintenance cost or service cost will be very much in increased strategy that will be depending upon the utilization. So when you have been compared with respect to the time basis, the resale value when it has been prolongated, the service cost or maintenance cost has been increased furtherly, automatically it is being nothing but the resale value for that particular product will be very much less. So here the question it is as per the previous problem. So the previous problem is this one. So that is machine is continued up to the average cost when machinery decreases by including overall the cost as replacement time. So when it has to be replaced, that has been given here. And here the similar strategy, but when it reaches up to the 500, that is resale value is gradually decreasing up to the 500, determine the proper length of service. So how many years of service, whether the given 5 years of service term period is being eligible as per the given question or not, based upon the consideration of this increasing in cost and continuously performing the service and depending upon the cost, running cost on the particular vehicle. So just we'll have a minute look over this. As per the manufacturing strategy, machines in a factory, as per the factory, the lifetime for that particular bike, let us assume that particular vehicle is a bike, and the manufacturer decided that replacement is necessary in the fifth year. But who doesn't have a compulsion that it has to be replaced only in the first fifth year. It can be replaced within the 2 years, maybe in 3 years, maybe in 4 years. That will be depending upon the service orientation. So service orientation will be depending upon the type of utility. So here we'll be having a detailed look as per the given utilization system within year by year. We'll be having a detailed look. That is running cost in the first year it is 1800. In the second year when it has been compared 2200. Third year 2700. Fourth year 3200. And in the fifth year 3700. And resale value is already given that the resale price drops as time passes until it reaches a constant value of 500. So constant value should be maintained. That is, for the any 2 years should be maintained the similar value. So in the fourth year and fifth year, it is maintaining that 500 rupees of resale value that is coinciding with each other as per the given tabular column. So whether it is preferred to replace in fifth year or in the fourth year itself it has to be replaced. So what is the difference that is being existing, lane difference that is being existing in between this fourth year and fifth year? Just will be having a look. So here considering that utility is nominal, that is and only single person is being utilizing that vehicle or bike. Now let's have the data here, that is year of service here have been taken at column number 1, 2, 3, 4, 5, 6, 7, and 8. 8 different columns. Asian column, first column comprises of the year of service, and second one it is running cost, third one it is cumulative running cost, fourth one it is resale price as it has been specified, and next one difference between initial cost and resale price, initial cost and the resale price. And initial cost has been given, that is 3500. Initial running cost is 3500, and average investment cost per year, average running cost per year, average cost per year. So totally will be analyzing one by one. In the case of first one, after commencing from the first year, the running cost it is 1800, And cumulative cost in the sense there is no any additional cost that has been performed over here, and simultaneously it will be of similar in value. And resale value already given in the tabular column, that is 1900. The resale value is increased after 1 year. So initial cost, that is simultaneously the average cost that is being spending is 1800. Initial input cost it is 3500, and resale value it is for 1900, right? So just will calculating the mean difference between the initial cost and the resale price. So yeah, the resale price is 1900 and original input cost is 3500. So 3500 minus 1900, that is 1600. And now we'll be having an average cost per year. So what is an average cost? Overall 5 years divided by only 1 year, that is 1600, right? Divided by only 1 year, that is cost per year we are being calculated, and hence 1. So 1600 by 1, that is only 1600. So average running cost per year, here the average running cost utilization, that is cumulative cost, that is 1800. So 1800 divided by only 1 year per year. So 1, that is 1800. So 1800, 1800. And average cost per year. So total cost that has been spent, nothing but this average investment cost per year plus average running cost gives the average total cost per year. That is nothing but this sixth column plus seventh column. Sixth column plus seventh column. 1600 plus 1800, 3400. And coming to the second point, second year, another one more year has been crossed away. And running cost it is 2200, that is specified in the question. And resale it is 1050. So 1050 here in the resale price column we have been written. So here, what is the next for the second year running cost? So for 1 year 1800. Second year it is 2200. Second year it is running cost 2200. So 2200. On and cumulative, what will be the cost? This 1800 plus 2200. Cumulative it is 4000 for 2 years. So this is for the second year, this is for the first year. And we are cumulatively considering for 2 years. This 1800 plus 2200, that is 4000. And resale value is 1050. So difference between the initial cost and resale value. So what will be the value? 3500 minus 1050. 1050. So hence 2450 is the difference prices. The average cost per year. Average cost per year in the sense here 2 years has been performed till now. This is for the first year and this is for the second year. So here 2450 divided by 2 years, and hence 2450 divided by 2, 1225. And average running cost. What is the average running cost here? So average running cost here specifies towards this cumulative running cost by for different number of years. How many number of years has been passed out till now, that need to be specified. And hence this cumulative running cost is 4000, and 4000 divided by how many years has been performed? 2 years. So 4000 divided by 2, 2000. Hence average running cost is 2000. So average cost for overall these 2 years when it has been considering for about 2 years. So average, whatever it may be, the total average cost, that is 2000 plus 1225. So finally value it is 3225. Vice versa, I will be calculating for simultaneously the third one. Running cost is 2700. Cumulative cost it is 4000 plus 2700, that is 6700. And resale price it is 600. And difference between that initial cost and resale value it is 3500 minus 600, that is 2900. And average investment cost it is nothing but 2900, and overall it is 3 years. 2900 divided by 3, that is 967. And average running cost, that is average running cost here specifies towards the total cumulative cost per years. So 3 years has been performed, 6700 divided by 3, that is 2233, and the average cost per on an average of this overall 3 years is 967 plus 2233, that is 3200. Simultaneously for the fourth year, running cost is 3200, average or cumulative running cost it is 6200 plus 3200 for about 4 years, that is 9900. And this resale value is 500, and we all have the clearly in the question that it maintains up to the constant value of 500. So in the fourth year we are getting this constant value, fourth to fifth there is commonly the resale price it is 500. So coming to the fourth year, 500 is the value. The difference between initial value and the resale value, initial value it is 3500, after 4 is resale value is 500, and hence the difference it is 3500 minus 500, 3000, and average cost per year it is the total difference value per the number of time or nothing but years of time passed away, that is 3000 divided by 4, that is 750, right? And next one, average running cost per year. Average running cost per year is related towards the cumulative running cost divided by number of years passed. So 9900 divided by 4, that leads to 2475. And average cost, average total cost that has been performed relates to the average investment cost per year plus the average running cost per year. That is 750 plus 2475. That is 3225. Alright, 3225. And for the next year, if you have been considering, there is a common stimulus value. Common stimulus values. So it is 3700, and cumulative cost it is 9900 plus 3700, that is 13600, and resale value is 500, and difference value is similar, that is 3000, and average cost it will be of 600, that is 3000 divided by 5, that is 600, and average running cost per year, that is cumulative running cost per years. So 5 years, that is 600 by 5, that is 2720, and average cost per year will be of 600 plus this 2720. So here it is 3320. So until there is an one complicacy, that is nothing but until the constant resale value is attained, then approach the replacement strategy. It is an initial strategy that in the question it is been specifies. Nothing but resale prices drops at time passes until it reaches as a constant value of rupees 500. So yet the constant maintenance of this resale value on an overall time period, that is in number of years, at what preferred length of service that machinery should be replaced, and overall cost data that has been asked by us. So here the commonly maintaining similar resale value in the fourth year and automatically in the fifth year. So it relates towards a feasibility by generating the values. So most probably it is getting started of similar range of value in the fourth year itself. It is already specifying that in the fourth year and fifth year, clearly it is 500 the resale value. And the user at an optimal strategy will be discussing that if it has been replaced in the fourth year itself, the maintenance cost of additionally nothing but the running cost of additionally 3700 will be in safe mode, and that can be utilized for the investment in enhancement or replacement of that particular machinery. So hence will be, for an instance, if the fifth year also has been maintained in the similar strategy, after crossing that, the efficiency in the fifth year will be very much less when compared to the previous year, maybe in condition, but not an exact manner. And as per the resale price has been considered will be of similar in the next year. If even 1 year has been got in weight position, there is no any change in the resale value, and hence instead of generating additional running cost on that particular machinery additionally, so replacement is necessary in the fourth year itself instead of saving the running cost. That leads to differentiate the n number of costs, that is average investment cost per year, average running cost per year, average cost per total overall years. So hence it is preferred to change or replace the machine in the fourth year itself. This is the second condition. So in the initial condition it is time bound condition, and here it is amount based conditions with respect to the time basis. That is the second constraint. Moving on to the third condition. So first condition it is an amount accessory with respect to the time basis, and the second condition we have been looked just now, that is time bound in a constant basis with respect to the cost efficiency, and in the third case we will be seeing in detail. First question, machine A cost of rupees 9,000, annual operating cost or rupees 200 for first year, and then increases by rupees 2,000 every year. So here it's clearly specifying that annual operating cost in the first year it is 200, and in, for the next year it is 2000 plus 200, that is 2200, and later on in the third year also it is increasing by 2000, that is 4200, and in the next year that is 6200, vice versa. So determine the best age at which to replace the machine. So by calculating upon year by year as per the conditions that we are being existing, that average maintenance cost is equivalent towards the total maintenance cost, then the replacement is necessary. When it is less than in condition, it is not at all necessary. When it is greater than in condition, compulsory the replacement is necessary. So those are the conditions that are existing in front of us, and we'll be moving forwardly to the question. If the optimum replacement policy is followed, what will be the average yearly cost of owing? So if the optimal replacement policy is followed, here clearly specifying in the question that the conditions given in the replacement theorem need to be applied here, right? So if the optimal replacement policy is followed, what will be the average yearly cost of owing and operating the machine? So what will be the cost? And that cost will be continuous, that assume that the machine has no resale value when replaced. So these are conditions. So replacement until it has been got no loss condition and no gain condition, there is nothing but resale value is zero, no sale, no resale value, and hence that is zero. When the entire machinery came into an halting position, and hence it is furtherly cannot be utilized for any kind of processing and doesn't have any future cost, and hence that is a no resale point, 0 point. At that until that particular position, you need to calculate that year by year 2000 will be getting increasing gradually, and in which year, as per the optimal solution or optimal conditions, that is we are having average maintenance cost should be uh, greater than maintenance cost. If it is greater than the cumulative operating cost, then replacement is necessary, and if it is less, the replacement need not be in referred in reference, or it cannot be referred. This is the condition need to be maintained, and The future cost will be discontinued. So this is the overall given question, and based upon this, we'll be looking after the solution related to it. First one, assuming for about 5 years of strategy, commonly we are taking. So as far as the given question, in the first year the maintenance cost is 200 rupees, and for the second year it will, from the second year onwards it will be increasing by 2000. So in the second year it is maintenance cost 2200, third year it is 4200, and fourth year 6200, and fifth year 8200. So you cannot assume that it will be gradually taking sixth year also. So why we have not considered this sixth year? Because as per the given question, we are having the total input cost of the machinery is 9000. So this maintenance cost should not be increased than the 9000. And hence, if we have been taken the sixth year also, then it will be of 10,200, where it is exceeding the total investment cost of the machinery. And hence, for that condition, we are not taking the sixth year, right? Because we are having that average maintenance cost should not be greater than the initial input cost, and hence we are stopping with fifth year. Clear? So the main objective for us is to find the average cost per year of a machine. So we have prepared a following table, that replacement consideration for each and every end of the year. What is the total running cost, and what is the depreciation cost? So here we need to find out the depreciation as per the given question, and what will be the total value or total cost, and what will be the average cost value of the depreciation, that we'll be finding out. And we are also having a clear cut statement that at the time of the replacement there should not be any or no any resale value for the machinery. So coming to the first year, total running cost it is 200, or maintenance cost it is 200 running cost, and depreciation it is nothing but the 9000, that is total cost of the machinery. That is also should be monitored, and the total cost it is 9200. So average cost also will be 2000, 9200 for 1 year. All right. Moving on to the second year, it is 2200 for the second year, but in the first year we have been already have a maintenance cost of 200. So 200 plus 2200, it is 2400, and the depreciation cost it is common because there is no any changes in the replacement value, right? So 9000, and the total cost it is 9 plus 24, that is 11400. So average cost it is for about 2 years, so 11400 divided by 2, 5700. Coming to the third point, third one, it is total running cost 2400 for 2 years plus 42, that is 66, and depreciation it is common, that is 9000, and total cost it is 9 plus 66, 15600. And moving on to the average cost, that is 15600 divided by 3, that is 5200. Moving on to the fourth year, it is 6600 until the uh, 3 years, and fourth year it is 6200. So 6600 plus 6200, it is 12800. So 12800 total running cost. Hence we are having the condition as per our strategy, that is it should not be crossed total running cost or total average cost. Total maintenance cost should not be exceeds towards the maximum input conditions of cost. Hence 12,800 is greater than the input cost of the machinery, and it's not be preferred furtherly, right? And hence 6,600 plus this 6,200 is 12,800. Depreciation is common, and upon addition 21,800, average that is divided by 45450, and the initial strategy is total running cost should not be greater than this cost should not be greater than the basic cost of the machinery, that is 9,000. Hence it is not feasible. And the optimal, as per the optimal solutions in the question, it has been clearly given that the optimum replacement policy is followed, so that a certain but condition need to be followed. There is investment cost should not be crossed by the total running cost, as it has been crossed. And the fourth year, it should not be replaced. Before itself, it has to be replaced. And before maximum condition, it is arising at the third year. So third year it is 66 plus 9, and average cost it is 5,200. Hence, from the table, it is very much clear that the average cost in the given question also will be of 5,200, and in the third year itself, the replacement is necessary. At the time bound has been considered in which year or at what time it need to be replaced. We had a good question, and hence in the third year itself, it need to be replaced, and until the third year completes, as per the given question, if it is first year for 2,200 increment, 2,000 maintenance, 200 maintenance cost, and later on 2,000 increment. So based upon that, the average cost of maintenance is 5,200 for about this 3 years, and the machinery has to be compulsory replaced by the end of this third year, end of this third, because we have been considering to the end of the year, and hence the as per the condition that it should not have the any resale value, and hence there is no any resale value. Clear? And hence the average yearly cost is 5,200. Definitely the machinery need to be replaced with no resale value of at third year itself. Clear? We are simultaneously looking after another one more problem related to this case number 3. A machinery cost of rupees 10,000. Annual operating costs are 400 for the first year and increases by 800 every year. So first year it is 400, and later on, if the second year has been considered, it will be 1200, 8 plus 4, and later on there is 12 plus 8, 2000. Vice versa, it will be increasing year by year. We have a machine of type A, which is 1 year old. So 1 year old machinery, should you replace it with B? And if so, when? So when it has to be get replaced? It is the question. So here in the question there is no any relations that need to be followed. So hence we will be taking the conditions that replacement policy or theorem conditions we have to follow directly. What are the theorem conditions that we are having? So replacement should be considered when the total running cost is crossing the input cost of the machinery. So if it is not crossing, then we can run the machinery. So taking the, as per the given question, considering the tabular column, for the first year it is maintenance cost of the machinery 400, and for the second year, from the second year onwards, 800, 800 increment. So 400 plus 800, 1200. For the third year it is 12 plus 8, 2000, and fourth year it is 2000 plus 800, 2800, 5, 6, and so on, 800 increment. So we'll be following what is the feasible year need to be maintained for replacement. So to find the average cost, similarly we'll be tabulating the tabular column that by the year end we are considering year by year, first year, second year, like that. So maybe we can find out these December as an year end, or else the financial year, if you can consider this, March will be the year end, and hence condition here, total running cost, first one it is initially 400, and depreciation cost it is 10,000, and hence there is no any specification regarding the resale value in the question. And by that, there is a hint for us that it is an case 3 kind of problem that involves both the time period as well as this cost basis. And hence depreciation it is 10,000, that is will be a constant for n number of years until the replacement is required. Here n here refers to the replacement, until the replacement. So as replacement we have to verify that when it has been crossing the input cost or depreciation of the input cost is being crossing by the replacement, then compulsory the replacement is necessary. That is what the total running cost. Running cost. When the input cost is being equated with respect to the total running cost, else the total running cost is greater than the total input cost, then the replacement is quite necessary. That is the main condition for this. And year by year we are taking. First year it is 400,000. The total cost is 10,400, and average cost it is for 1 year. So 10,400 divided by 1, that is 10,400 common. And if the second year has been considered, it is 400 plus this 1200, that is 1600, and depreciation is common, and upon addition or total cost, that is 11,600 divided by 2, because average is 2 years. So 11,600 divided by 2 is 5,800. And in the third year, 3,600 is 1,600 plus this 2,000. So 3,600 depreciation cost is common, and total cost per year is 10,000 plus 3,600, 10,600, and average cost it is 13,600 divided by, for about 3 years, divided by 3, there is 4533.33. And for the fourth year it is 6,000, total running cost it is 3,600 plus fourth year 2,800, 3,600 plus 2,800, it is 6,400. So depreciation cost is common, and then no resale value formula is followed here. Total cost it is 10,000 plus 6,400, 16,400 for about 4 years the average cost. So hence 16,400 divided by 4, 4,100. And for the fifth year it is 6,400 plus the fifth year it is 3,600. So 64 plus 36, that is 10,000. And depreciation cost is 10,000. So total input cost of the machinery is 10,000, and total running cost is equating with respect to the depreciation cost. In the previous problem, we have been found that total running cost is greater than the depreciation cost, and in this particular problem, it is equating with respect to the depreciation cost. Hence, total cost it is 2,000. For about 5 years, 20,000 by 5 is 4,000. So the total mean average cost is 4,000 is spent for about 5 years, and the replacement of that particular machinery is necessary at the fifth year, and the condition for that it is the total cost is equating with respect to the total running cost in the fifth year, that is 10,000, and the average cost it is 4,000. That is the condition, and hence this is the third case of the problem, and furtherly we will be discussing regarding this in the next class. Thank you.